So this is another lesson for biopsychology from the AQA syllabus, Psychology Paper 2. We're looking at biological rhythms today, and we're going to specifically focus on infradian rhythms. Just a reminder, infradian rhythms are biological rhythms that take longer than a day, and an example here in the glossary is the menstrual cycle. We'll also be looking at seasonal affective disorder. As all other biological rhythms, they're periodic cycles that happen regularly, only that the regularity of these ones is less frequent than circadian and ultradian rhythms. So just a reminder, for circadian rhythms, you can look at, for example, the sleep-wake cycle, body temperature, and hormonal fluctuations. For ultradian rhythms, you will look at stages of sleep, specifically the distinction between REM and non-REM sleep. And for infradian rhythms, we will look at today the menstrual cycle and seasonal affective disorder. We will start by looking at the menstrual cycle AO1 and then the menstrual cycle AO3, and then do the same sequence for the seasonal affective disorder. This is also good strategy. Should you get an extended question on infradian rhythms, you might want to split it into AO1s for menstrual cycle, AO3s for menstrual cycle, and then again for seasonal affective disorder. So you might not see this, but as for circadian rhythms, you can organize your AO1 into the role of endogenous pacemakers and exogenous zeitgebers. So you will look to what extent the menstrual cycle is dictated by internal factors such as estrogen and progesterone, and to what extent it's determined by external factors. And we will see that in this case, the external factors are other women, other people on a cycle, so synchronization, and linked to that the role of pheromones. And then when we look at evaluation, remember evaluation AO3 is evaluation and analysis. So you can analyze synchronization, for example, as having evolutionary value. You can also look at the methods that are used to research the menstrual cycle and to what extent they have internal validity and to what extent they have issues. So, as you might already know, the menstrual cycle is controlled mainly by the hormones estrogen and progesterone. So these are the endogenous factors that determine a menstrual cycle. You would want to go into a bit more detail and say that estrogen causes the ovary to develop an egg. It's released, and this is called ovulation. And then progesterone helps the womb lining to grow thicker, ready for pregnancy. But if the egg isn't fertilized, then it's disposed. So the menstrual cycle is the result of this disposal. Now, external factors here are synchronization. It means that being around other people on their menstrual cycle can change the cycle of one's own menstrual cycle. Martha McClintock studied this, looking at women that lived in all-female university dorms, and found that there was a strong positive correlation between how long people were exposed to each other, so spent time together, and how closely they experienced their menstrual cycle. So this emphasizes the role of pheromones. Pheromones are like our hormones, but released into the outside world through our sweat, our body smell, our skin. Basically, our skin conducts these pheromones that send signals to others about our internal mechanisms, and therefore might influence their internal mechanisms. So there's definitely a question here for your AO3 as to whether pheromones are considered internal or external, because they're released into the outside world, so other people's pheromone can influence us. But then again, they're a biological factor. So that's a good analysis point. As I said, there's in terms of exogenous zeitgebers, there's isolation studies like in the circadian rhythms. You remember Sifre. So here we've got another study, but this time it's a woman who spent 3 months in a cave with no natural light, and it was found that her menstrual cycle shortened. And this shows that light is also an exogenous factor that might be implicated in the menstrual cycle. So not only pheromones and exposure to other individuals, but also the presence of our absence of the light seems to synchronize not only the sleep-wake cycle. So moving on to AO3, we can talk about the evolutionary value of synchronization. If women are menstruating at the same time, they're also ovulating at the same time, meaning there's a higher likelihood of them getting pregnant at the same time, and therefore the children being born at the same time. So if living in a group, in a tribe, that might make it more effective in terms of sharing the care of babies, lactating at the same time, etc. Also, competition for males is fairer if all women are either fertile or not fertile in sync. There are arguments against this. As you can see, Shanks argues that it's not really true that for women, competition promotes survival. Women are more kind of tend and befriend rather than fight or flight genders, and therefore the idea that that competition is at the basis of synchronization doesn't really have a sound basis. There's also research to support synchronization. This is a slightly disgusting study where participants placed cotton wool under their armpits without deodorant, so the cotton wool was impregnated with sweat, and then that was swiped on the upper lip of another participant, and that was to expose that participant to the pheromones of the sweating participant. And they did find that through smelling the pheromones of the other participants, the ones exposed to the pheromones did seem to synchronize, or their period get closer to the kind of the donors of the pheromones. So this is supporting evidence in a kind of standardized controlled study beyond just looking at young people that spent time together in dorms. That is, yeah, more naturalistic, more with high ecological validity, but not with a high control of other extraneous variables. So this seems to substantiate the role of pheromones in synchronization. Now, generally speaking, there are other questions about synchronization. The first one is that mathematically, women are bound to synchronize at some point in the course of 3 or 4 cycles, especially because the length of cycles is not the same for everyone. So it's based on the flawed assumption that everybody's cycle is 28 days, for example. So there are kind of mathematical reasons whereby synchronization could happen just by chance rather than because of exposure to pheromones. We're moving on now to the second infradian rhythm. So we're going to look at the AO1s for seasonal affective disorder. First of all, seasonal affective disorder is a specific type of depression that is similar to depression in terms of its symptoms. However, it only occurs during the winter months, and this seems to be attributed to the low levels of light. The symptoms include low energy, hypersomnia, that means sleeping too much, overeating, weight gain, and social withdrawal. So spending a lot of time alone, at home, either sleeping or eating. This is what it suggests. Now, for seasonal affective disorder, the endogenous pacemakers that are involved are the overproduction of melatonin that results in the underproduction of serotonin, and the exogenous zeitgeber is the absence of light, and therefore in the winter months we know that the days are shorter. In terms of AO3, we don't have a lot. We have phototherapy, that is practical application of our knowledge into the reasons why SAD might occur and how we can treat it. So melatonin is a hormone. The endocrine system is the system of glands that secrete hormones. So if there's an overproduction of melatonin, there will be a strain in the pineal gland that might result in an underproduction of other hormones within the endocrine system. In this case, the hormones that might be influenced are the thyroid hormone, serotonin, and adrenaline. So it makes sense to think that if you're producing loads of melatonin because it's nearly always dark, then you will be producing less of that mood regulating hormone, serotonin, the thyroid, meaning that you might feel hungry when you don't need food, and the lack of adrenaline might not motivate you to go out. So it does link to all of the symptoms that we described earlier. Sad patients have consistently higher daytime melatonin levels. So there is empirical evidence that seasonal affective disorder does seem to be linked to a higher melatonin level. So there is maybe a hypersensitivity to light and darkness in these individuals, and that is linked to all the symptoms that we described. Light is obviously the exogenous light gain involved here. In winter, we know that the daytime hours reduce significantly, maybe to 5 or 6 hours a day of natural light. If you consider also people maybe having a 9-to-5 job, it means that they will potentially never be exposed to natural light in the winter months. So for AO3, we can look at the evidence that light is implicated in seasonal affective disorder because phototherapy, that means light exposure, is effective. Yeah. Here we've got Eastman treated seasonal affective disorder patients with bright light or a placebo, and they found that those treated with the real light rather than the placebo were more likely to respond. And sometimes they had a full remission of symptoms, meaning they weren't clinically depressed anymore. However, 60% of sufferers found a reduction after treatment, but 30% seem to improve after a placebo. So there's the question as to whether light or other factors, psychological factors rather than exogenous light givers, are also involved in seasonal affective disorder. For example, in the winter months, our bills will be higher because we have to use more artificial light, so our electric bills will be higher, our gas bills will be higher because we have to keep the heating on. In the winter months, we have Christmas, that although it's very festive, for some people could be very depressing, especially if they don't have close friends or family to spend it with. It might make them feel very lonely. And also lifestyle. In the winter, you're less likely to go out, you're less likely to go out for a walk because it's cold, because it's dark. So those might also be factors that exacerbate people's low mood. These are all confounding variables because they go along with the winter months. We can't separate them and study them. So they're not extraneous variables that we could control for. They're confounding that do impact on what we're researching, and there's basically nothing we can do about that. Lastly, another factor that has to be noted is that not everyone exposed to reduced daylight develops seasonal affective disorder, because everybody is experiencing winter months, but not everybody is falling into depression. So that means that there are genetic predispositions, overall issues with mental health that make it more likely for some people than others to develop seasonal affective disorder. Therefore, questioning the extent to which it is a matter of exogenous and endogenous factors and whether it's something completely separate.